We're inundated by brands and marketing and ads all the time. And there's lots of well-known brands, brands like Sony and brands like Nintendo or Intel. There are a lot of brands that we can recognize even if we're not in that field. Few brands, though, elicit such loyalty and love that people will go to the extremes of tattooing their body. And I only really know of two brands that can do this. Apple, and I've seen Apple tattoos, the picture of the little apple with a bite out of it. But by and far, Campagnolo has way more tattoos than any other company I have ever seen. There is no company that seems to create a loyalty and a love such as Campagnolo. Now, both of my bikes currently have Campagnolo equipment on them. Both of them are EPS. Neither of them were designed for electronic group sets, and neither of them were specifically designed for Campagnolo equipment. So I wanted to summarize some of the hacks that I've been doing over the last few months and years, and then we'll talk about one that kind of solves an EPS specific problem. So these are all electronic hacks. They're all relatively simple, except for the last one, but they all add some level of competitiveness or some level of functionality that doesn't currently exist. So with that, let's get to it. So perhaps you have a new modern frame and it's designed for external cable routing. Well, that's not a problem. But one of those problems you may encounter is, how am I going to get my front derailleur connected and my cable ran correctly? With that, that's hack number one. Modern frame, front derailleur, EPS. So why is this cable coming out of the bottom bracket here? And what's this on the cable? Well, it's a bit of a patch job. See, I cut the cable, ran it through, and then resoldered it down here. So there's 6 connections inside, and then I have the big heat shrink over it. And that cable runs through this little bolt down here. So I actually had to design and build a 3D printed extender. There's an aluminum one on the way, but this is temporary for my friend. And you can see, like, there are holes through the bottom bracket into the seat stay and all throughout the whole bike. So even though it's an externally routed frame, there's still lots of things that you can route internally. And like the rear cable here, I mean, it's externally routed, but there's obviously a hole through it. But that front derailleur, yeah, I would have went through this big giant hole in the bottom, wrapped the cable around. But that's me. You want a really clean look on your bike, and you want an EPS system. So you're kind of stuck with zip ties or O-rings to kind of hold on to that interface to your stem area. The other side is it makes the charge port directly on the bottom, and it's really hard to see, and people struggle with plugging them in. There is a lot of damaged pins out there. It's a common problem. So maybe for me, I can add some convenience, and for others, I can add some improvements to this aesthetics. So with that, hack number 2 is an integrated stem spacer that has a interface mount for the interface version 3. That's number 2. I wanted a new way to mount the interface that wasn't using straps. So I printed something, a slide in here, plug in through the bottom, pretty standard, threw my website on it, and printed it. And I printed in this direction, but while it made it strong in this direction, it snaps off in this direction. There's nothing I could really do about that. So I redesigned it so that it charged from the side. And you'd slide it in from the top, but all the layers wrap around the whole thing. So now it's strong for the cantilever bit, but also the piece that goes around the stem. So all the files for this is available in the GitHub, linked below. And I just wanted to show how, you can go through the layers. I use a high degree of infill in this area, primarily because I want to make it really strong. It's not 100%, I think it's a 40 or 50%. And then you just, 3D print that on your cheap 3D printer. Pull off your top cap. Undo your stem bolts. Now obviously this is only going to work if you have a few spacers on it. You actually need about 20 millimeters because you need a 10 millimeter gap, and you want 10 millimeters-ish for the spacer for the actual mount. So sorry, slam your stem folks, you know, no love for you here. So you can see I'm going to slide that down on. It was a bit of a tight fit. Install my second spacer, slide in the interface, throw back on my, my stem, and top cap. So tension's top cap. Didn't catch that on video, but then once you do that, torque all your bolts and you're good to go. And it's worked out pretty well for a few rides. One of the really good things about the Shimano Di2 system is the infinite level of configurability. You can use up to 6 shifters, and like not just climb and sprint shifters, I mean any shifters. You can use mountain bike shifters, you can use road shifters, you can have 3 left and 3 right road shifters and it'll still work. Unfortunately, us campy guys, we can't do that. Or can we? The wiring is actually really simple on a lot of this stuff. It's very sensible, and it's pretty easy to add some of that functionality. So with that, hack number 3 is going to be adding some climb or sprint shifters, depending on how you want to look at it. So that's number 3. I started the switch design for my Di2 hack, but I figured I can reuse it here. And this was the first generation of the button design. I scaled it up actually. It was about half the size of this. And I realized I needed to print it in that direction. But yeah, it was okay, but again, the printing issue. So try again, make a few adjustments, and it prints cleaner on the back, you know, but it's a bit of a mess inside. And then trying to create a mount to hold the actual button fixture was a real pain in the butt. So I figured I'd start with something basic. Let's get a box, and let's make a box work with the movement I want, and then we'll work out from that. And I had to print this multiple times, and this surprisingly was the best one I had. I get the little cover in and said, all right, we'll flip it over, and no, I designed in extra tolerances, but I realized this material, as opposed to the first one I started with, is kind of flexy. It has a bit more give. So I made this C shape, printed in this direction so it's strong and there's no layers to crack. And would you look at that? Just a great movement. So it evolved into this. This one was just flat. And then I made some space, some internal cutout space for the switch and some connections. And then, you know, different sizes. Change the gap, change how the wires might come out. So this is on the Di2 hacking stuff that I've been working on quietly. And you can see this one fully surrounds it. You've got those wires coming out on the side here, same with these ones. This one's only a partial one. But after purchasing 8 different click switches, I got the click switch and feel that I thought I wanted. It's also a little bit stretchy, some design changes to make sure that with the stretch it still clicks. But generally, this is pretty good. I need to work on the waterproofing next, but I've been using this on my bike, and here's a little bit of a demo. So they work pretty well. And the 11-speed EPS is just kind of a dumb setup. So I made these 2 extensions, and essentially there's one wire to ground out the other 3, and the other 3 correspond to shift up, down, and mode. So yeah, I just tested them with some little bit of tape to hold them in place. So take that off and we'll do a little bit of an upgrade. But yeah, so you can just splice into these wires anywhere and run them out to your own shifters. It's best not to do this on the hydraulic setup because there are some detection circuits in them, but works pretty well on the old, dumber, original 11-speed. So if you want some climb shifters or sprint shifter type things, Yeah, it's great. I'm using some two-sided adhesive film from 3M here. I'll link the type in the description if you want to find it. DigiKey is a great supplier of this stuff, so you just slide that on and you'll have a little bit of ability to move it, but once you press it down, it's pretty secure. I'm not riding this bike in the rain or anything, but yeah, it works the same. The left side, obviously, you can see how I've ran the wires through the stem here and through the gap in the bike mount. And yeah, so I have to be a bit more careful. But it's the same procedure. Put the adhesive down, peel it up with my knife this time. Put it on, and then you have a little bit of adjustment. Wiggle it into the right placement, and then press it down. And with that, you just close up, in my case, the Garmin mount, and that's it. And it's back to shifting. Let us say that you want a retro bike, something of that kind of nostalgia, Eroica era, and you find something, but you want the performance of a modern group set. Not only that, and to the dismay of all of your colleagues, you want to put an electronic group set on it. It's not even designed for a modern mechanical group set, though generally 100% compatibility within some limits, but definitely not an electronic group set. And sometimes there's challenges with that. And sometimes it can come up with some cool solutions. So with that, hack number, we'll call it 4, is retro cable routing for the EPS system, along with let's relocate that interface. So electing to put my interface on my seat post meant that I had to run these cables all along the top tube, and there was no way to do it inside because I couldn't get past the seat post. So I used some heat shrink tubing with the brake cable, and that just ran all along here and into the interface. Mount it with your standard Campagnolo rubber band thing, but I drilled a hole and I had to cut and resolder, and you want to do this on the interface side. The front derailleur just runs down the back, not even really visible, while the rear derailleur has a zip tie, but also I'm using this frame protector tape, and that makes it very hard to see that there's anything there really from the outside. And then going underneath, another zip tie to secure the rear derailleur, make sure it's out of that wheel. But these drain holes are a great way to run cables inside, and the cables are durable enough. So if you've got a retro bike and you want to run electronic group sets, you don't need to worry about it. There's methods of doing that for all bikes without detracting from the visual. So over the years, the EPS system has evolved. So there's V1, came out in 2011, 2012, and V4 for the 12-speed system now. And in all that time, the charger really hasn't changed. V1 had a different connector, but it's essentially been the same thing throughout. The unfortunate thing is on V2, the charge port was a cable connected to the power unit. On V3, it added the convenience of putting it into the interface. But where do you put the charger? The cable is only like this long, and the charger is big and kind of heavy. So there needed to be kind of a solution, and with Shimano, you have this tiny little micro USB charger. Worst case scenario is I can plug it into a laptop or any of these USB outlets that I can find around. But with Campagnolo, you can't do that. And I think that needed to be addressed. So I went about designing and building my own EPS charger, one that runs on USB. And also it has to charge a little slower to deal with some specs, but a micro charger is hack number 5. We're going to add in about a 5A though for the regular chargers to try and help you out though. So this little project, hopefully I'll have it in my Tindy store and all the schematics and stuff on GitHub, but order up a PCB, all the parts from DigiKey, this little module from China that boosts the voltage from 5 volts to up to 40, but we're going to need about 13 or 14 volts. And the PCB is designed just to mount on the back in actually this orientation, and gives a pretty small, slim form factor. So I've set the boost to be about, if I can get it to read, 13.4 5 volts here. You need about 0.6 over the maximum voltage of the battery, which is 12.7. Set the charge current to 100 milliamps, so it's slow. It's much slower than the original unit, but it can use any USB port. Blue light for charging, because blue light's way cooler, and we were at 100 milliamps, so we're less than 12.6 volts, and sure enough, yeah, 12.1617. So now, testing for the NTC, there's a little temperature sensor in it called an NTC thermistor, and when I change this potentiometer to simulate that, yeah, it disconnects the charging. So, have to connect all these things together and 3D print some different boxes, and that's what I've got here. There's a couple of mods, so the design has to change a little, so some hand waving there. But yeah, the 3D printed enclosure. There's actually 2 designs now. I'm not sure which I like better, but you just pop it in, snap on the lid, and yeah, you're ready to go. Plug a USB adapter in there. So as a comparison to the use case, look, here's your standard charger, you plug it in, light comes on, and you plug it into your interface. So with this non-standard positioning, works out pretty well. Light comes on to charge, and where am I going to put this? Well, the little brake mount. But on a front mount, the standard where everyone puts these things, plug it in, but now what am I going to do with this? I can't hang it off. It's way too heavy. It'll damage that little connector. Or in my case, you just end up unplugging it accidentally as you futz around. You can hang it off the wire, or you can kind of like lay it on the handlebars or precariously perch it. Whereas this little guy, he's super light. He's, you know, within the limits of probably pretty much acceptable for a mount like this if you screw it in correctly. And just plug in the USB and boop, lights are on, power, and it's charging. Or power it and yeah, you futz around a little bit with that connector, light comes on, but you can just dangle it there because it's light enough now. It's not a big deal. Alternatively, what if that wire was really long? So I made this one out of some scrap, but you can get the underseat cable, or you can buy the actual connectors off of DigiKey, build your own extension cable, saves you from damaging the connector on your EPS charger, and you know, worst case scenario, you're out a secondary cable. But now you've got all this long cable, and it'll charge fine, long enough to reach. If you found this useful and you want to try some of this stuff for yourself, like the bottle cage relocator or the 3D printed stem for the V3 interface, all the design files are located in the GitHub below, including the design files for the microcharger. Now, some people might not want to go get circuit boards, ordering parts, and putting some stuff together. So I do have enough parts to build a few of these units here. So I've set up a Tindy store, and the price kind of covers most of my cost and labor. It's not a high volume production piece, and the cable and the chip that I use in this are actually really expensive. So mainly just trying to cover costs for that whole project and the design. A few future updates will probably happen in the GitHub. And as always, if you like this content, please subscribe, ring the bell, you know, notify, write a comment down in the doobly-doo. And if you have a suggestion for a stem angle, currently there's only -6 degrees in there. If you need a different stem angle or length, it's all parametric, so I can upload a file pretty quick. So yeah, if you need something like that, just drop a comment or drop me an email. The Titan Lab website is probably the best way to contact me. Anyway, thanks again.